Right, welcome back, ladies and gentlemen. As you can see, my voice does not work well, and I like to go through today's lesson using a online method. I think I need to take some time off. So sorry about that. You have these videos. So first thing first, we are going to finish Unit A, Chapter 2.1, which is Pure Substances and Mixture. So we're gonna play this video as a little fun experiment that you can do in home. All right, so last time when we talked about solution, let me give you a little bit review of what we did. First of all, middle school definition, middle school science. Sorry, not definition. I think this is more a little bit of smart cheating part. Solution, mostly you can see through. Because of one reason. Like, for example, you have a beaker, you have solution. Even if something is dissolved, you can technically look through another one. If it's something that you cannot see through, that means it's very concentrated. Like the coffee example over here. Theoretically, if it's diluted enough, you can see through it. On the other hand, bowl of cereal you cannot, because even if you try to see through, it's going to be blocked by the cereal chunk itself, particles if you will. So technically the homogeneous mixture, this part you can consider as one kind, one phase, one evenly distributed phase. You can think it in that way. That is a solution. So let's go through something that junior high student always struggle. Suspension. This is a type of a mixture. Oh my goodness, so ugly. There you go. It is a type of a mixture. Mechanical mixture, if you think about, they're not blending in. They do not collaborate well enough. It's different independent type of particle. They're just forced to be clumped together. Like pepperoni pizza. Cheese and pepperoni, yes, they're together, very tasty, but those are taste differently because pepperoni has its own protein, fat, salt, those kind of things. Cheese has its own lactose, fat, and also grease, those kind of things together. Now, suspension, if I highlight few things, it's a cloudy mixture, ladies and gentlemen, and you have a bunch of droplets or pieces of a certain chemical inside. The difference between suspension and colloid is when it comes to suspension, these chunks are generally chunks are large enough to observe. Also, another thing about suspension is you need to actually provide them some time. If you provide some time undistributed, like what your fill in the blank shows, then generally they separate out. What I mean by that is, look at this Italian dressing. You actually have oil layer on the top and then there's a solution layer. If you want to apply Italian dressing on your salad, you gotta shake this up, down, left to right, whatever. Then you can have a blended in solution, or in this case, sorry, mixture. But if it's left for about a minute or something, it's gonna come back to its separated state. If you look at this, can you see it's a some kind of, I think it's a juice and seeds. This seeds will, we call it submerge, submerge as time goes. Right now they're floating over there, but if there's more time given to these particles, due to the force of gravity, it's gonna sink. There are a lot of chemicals or drink that does that. It's maybe a little bit weird example, but if you have a bottle of milk and if you don't consume that milk and milk is spoiled for a long time, then you will have a little yogurt film happening at the top of it. It's very sour smell too, nasty sour smell because of fermentation process. I want you to know about that. It's a food fun fact. We already watched the salad dressing. Let's look at muddy water. It's even more disgusting. Sorry about that, guys. If you look at muddy water, this is after shaking and probably few minutes. Then you will know that the sediment layer are the one that will go at the bottom. On the top portion, this will be your H2O component, water. As you may notice, with time goes, suspension, they generally separated by whatever layer on the top and the bottom. Colloid. This is another type. People confuse colloid with suspension just because both are too cloudy to see. Yes, it's turbid, cloudy, foggy, but when it comes to these pieces, they're so small, so tiny that it cannot be separated out easily. What I mean by that is I want you to look at a bunch of examples that is given in here. Like, let's say honey. This honey or caramel, in this case toothpaste, as you can see, those are fluid, but they're very turbid, and at the same time, even if you let it stay for a long time, it's still gonna maintain that whatever the color of it. It's not gonna be separated because colloids, the particles or molecules, if I say, are too tiny that gravity does not affect as much. So look at my river or lake analogy over here. Let's say suspension, these guys are the one that floats on the top. Let's say, for example, algae, something like that. Colloids, on the other hand, is like a plankton. They can float around and go back and forth, but it's evenly distributed. Fish can eat it, something like that. When it comes to colloids, they do not disappear by having separated layer. They're just staying there. This is one of the reasons why the famous example is any type of milk product, because milk has its own color, which is, well, ironically white and nothing more else. So I want you to understand that even if you let it stay for a longer time, it's not gonna be, how can I say, it's not gonna change into like red color or something like that. Now, my class is done, believe it or not. Substitute teacher will provide you a assignment worksheet that you need to do. It is a homework. You can collaborate with others too. However, you do not and will not use the technology, aka internet, Google. You're not allowed for that. I want you to discuss though. That is today's class.